Ignition sequence starts.
Good morning. You're looking inside the International Space Station Flight Control Room, where a team of specialists is always on duty to keep a close eye on the systems of the space station. The Expedition 63 crew members are finishing up the tasks of their Friday afternoon and looking forward to a weekend of plenty of off-duty time to go with their regular weekly house cleaning and daily exercise. Commander Chris Cassidy and flight engineers Anatoly Ivanishin and Ivan Wagner are finishing up another week spent supporting scientific experiments, but they also oversaw the departure from the station of the last of its kind Japanese cargo ship.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Sandra Jones. This week, a cargo craft departed the space station, NASA and SpaceX target October for the next Crew Dragon launch, and students heading back to class can celebrate station science with a new website. On Tuesday, the Japanese Aerospace Exploration Agency's HTV-9 cargo vehicle departed from the International Space Station. NASA astronaut and Expedition 63 Commander Chris Cassidy used the Canadarm2 to release HTV-9, ending its 3-month stay in space after delivering 4 tons of supplies and experiments to the orbiting laboratory, including lithium-ion batteries used to recently upgrade the station's power systems. October is shaping up to be a busy travel month on the International Space Station. On Wednesday, October 14th, Soyuz MS-17 is scheduled to blast off from Baikonur, with NASA astronaut Kate Rubins and her Russian crewmates to begin their 6-month stay on station. 1 week later, Chris Cassidy, Ivan Wagner, and Anatoly Ivanishin will end their 195-day stay in space and land on the steppes of Kazakhstan. Following that landing, and now scheduled for no earlier than October 23rd, NASA astronauts Michael Hopkins, Victor Glover, and Shannon Walker, and JAXA astronaut Soichi Noguchi will launch from Florida on the first of a regular rotation of missions to the space station aboard the SpaceX Crew Dragon spacecraft. We are celebrating 20 years of continuous human occupancy aboard the International Space Station this year, and recently launched a website full of theme-based resources for students and educators. This month's theme is Back to School and features opportunities and resources for celebrating station science as the start of a new school year begins. You can participate from anywhere. Visit our website at nasa.gov/STEM/ISS20 and check it out. This week's question comes from 9-year-old Thomas, who wants to know if the International Space Station is falling or orbiting. Well, Thomas, the International Space Station is actually doing both. Earth's gravity is constantly pulling objects downward toward the surface, including the space station. As a result, the space station is constantly falling toward Earth's surface. However, it also is moving at a very fast speed, about 17,500 miles per hour. The space station moves at a speed that matches the way Earth's surface curves, so because of this, the spacecraft keeps falling toward the ground but never hits it. As a result, it falls in orbit around the planet. The moon stays in orbit around Earth for this same reason. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Today, we are just a bit more than 2 months away from a space station anniversary, the 20th anniversary of the arrival at the International Space Station of Expedition 1, which began a human presence in space that has been uninterrupted right up to now. In that time, 240 different people from 19 countries have floated aboard and taken a part in some of the more than 2,800 scientific investigations while getting humanity ready for future exploration out into the solar system.
This was once just a dream.
TTC go. TTC is go for launch.
2. Booster ignition and liftoff of Discovery and a team of explorers shaping their destiny.
An answer built by those who dared to ask, what if we were to channel humanity's knowledge and creativity into something truly revolutionary. What if we built a bridge between and above all nations? To jointly discover the galaxy's great unknowns, to endeavor to live and to work outside our planet for the benefit of all within. What started as an accord between two former rivals became a beacon of opportunity for the rest of the world.
We have ignition and liftoff of the Soyuz rocket, beginning the first expedition to the International Space Station and setting the stage for permanent human presence in space. You ready for visitors?
We live this dream aboard the International Space Station.
Understand it's good to have you there and adjusting to your new home.
Adapting to life in space. It's been a process.
For the past 20 years, over 230 astronauts from all over the world have worked tirelessly together, boldly performing pioneering research and high-stakes spacewalks in the unforgiving environment of space. In this unparalleled orbital laboratory, circling the planet at 17,500 miles an hour, thousands of groundbreaking scientific experiments from over 100 countries have led to discoveries unachievable in the confines of Earth. From 250 miles up, an unbroken chain of residents have shared their view and their research with a generation eager to understand this higher plane. The space station is a symbol of humanity at its best, a shining example of international peace and collaboration in action.
3, 2, 1.
Endeavour, this is Houston. You've completed a historic ride to the ISS and have opened up a new chapter in human space exploration.
And as we turn our gaze outward still, this International Space Station is a living testament of our collective strength and perseverance, where our human curiosity prepares for the audacious efforts ahead. We continue to bridge the distances between us and prove just how much more is possible when we dream together.
Here on Earth, we've all learned a lot lately about tracking the transmission of disease. Microbes live everywhere, and that's why scientists at NASA's Johnson Space Center constantly monitored the bacteria and fungi on the International Space Station. Now they're using DNA sequencing to identify the microbes in orbit without having to return samples to Earth for testing. That's an important step to keep crews and the places they visit safe on future deep space missions. The International Space Station's laboratory modules support experiments in a whole range of scientific disciplines. For example, the Flame Design experiment is looking into the quantity of soot produced under different burning conditions. Now, that could generate data that leads to the creation of new burners that are more efficient and less polluting. International Space Station crew members who support the research mission of the station get a large share of their training on the scientific payloads right here at the Johnson Space Center in Houston. Today, in the next segment of the new NASA Explorers series, we go to class with NASA astronauts as they go through training for a trip to the station.
Hi, I'm Terry Virts, and I want to talk about floating in space. One of the first things that you need to realize when you get into space is that even though you feel like you're falling, you're not. You can let go and you float. It's not a problem. It's something you really have to train your brain to think about. Another thing that you need to learn when you first get into space is how little force is required to move you. And another cool thing is you could be on the ceiling. It makes it very easy when you're working. You have to get some work done up here. You just go up on the ceiling and get your work done.
Our team of scientists is busy getting their experiment ready for launch. At the same time, NASA is preparing the space scientists who will operate the experiment aboard the International Space Station.
So as astronauts on board the space station, we are the hands and eyes of the researcher. They are telling us how best to do the science, but it's up to us to make sure that science runs correctly.
Astronauts train all over the world, including at NASA's Johnson Space Center in Houston, Texas. Here, they learn not just how to live in space, but also how to conduct science in microgravity.
So many folks ask, how much training did you do before launching to the space station? And the answer is many years. So we train in a lot of big areas. Number one is systems on board the ISS, robotics, how to do spacewalks, and actually science itself. Now, we don't learn about a lot of the science experiments we're doing until we get up there, but what they are teaching us is scientific techniques.
The techniques astronauts learn range from using tools like pipettes and microscopes in microgravity to operating scientific hardware aboard the space station. For example, we study combustion aboard the station because it behaves differently in microgravity. You wouldn't want fire to get free inside your home in space, though, so we've created special facilities to contain it. If it looks complicated, it's because it is. And it's just one of the pieces of equipment astronauts must master before they go to the space station.
Hi, I'm Tracy Neff, and this is Sharon Ranke, and we're in PDL2 right now, and we're down here at JSC to do the fluids and combustion facility training for the combustion integrated rack and the fluids integrated rack.
So basically, PDL2 is a mock-up of the US lab. Since 2008, we've been coming down and training all of the crew members who will do payloads on the space station. We've been training cosmonauts as well.
How many crew do you think you've trained at this point?
Probably 50, probably over 50 crew members we've trained.
Today, Tracy and Sharon are back at work with a former student, NASA astronaut Mike Fink. This isn't Mike's first rodeo with the station, or this equipment for that matter.
So back in 2008 and 2009, we were aboard the International Space Station when a space shuttle, STS-126, Chris Ferguson and crew, dropped off a whole big bunch of packages. And we carefully and slowly put it all together. But when it was all done, we had a brand new ready, fresh out of the box combustion integration rack. And since then, our friends at Glenn Research Center here at NASA, we've been able to get some fantastic science about how things burn in space. Without gravity, without convection, things burn. And by understanding that better, we're able to make more fuel-efficient engines and things here on planet Earth, helping save our energy.
So you can see it in the video. All the hoses are within the ring, and so they all fit in nicely, so they shouldn't interfere with us.
Sounds great and looks great. Thank you.
Well, a lot had changed in 11 years since he was up there. So he did get most of the information again, and it was a new experiment, so he hadn't seen that either. He did great. He's a quick learner. It's great to work with, very methodical, and good humor, which is always, we like to have fun when we're training.
But the lab camera will be showing,
we have
and
the camera.
I will be like looking, and I'm gonna go slowly, and that would be your chance to say no.
Yes,
Through
we
the
are watching you,
fake
yes,
off.
and help you whenever we can.
This isn't the last time Tracy and Sharon will work with Mike. When he launches to the station and works on combustion projects in space, they'll watch over his shoulder through a camera broadcasting to Glenn Research Center in Cleveland, Ohio.
Christina, this is Sharon with an answer to your question. So they do want you to go ahead and install the cable tie.
Copy all. Thanks for hunting that down for me.
Anytime.
Being able to operate and maintain the space station while conducting crucial research could get overwhelming. Luckily, astronauts have strong support teams on the ground and often develop personal connections to the research.
I was so impressed at the different things we'd be working on, cancer or Parkinson's or even Alzheimer's disease. So as a physician, these meant a lot to me. These personally were very important experiments that we needed to do. But in all honesty, the entire crew, not just myself as the physician, were excited about working on these experiments. You get a little nervous at first as you begin to pipette or even utilize a microscope, which I hadn't used in years. But you quickly learn because you realize how important it is to the science, and the investigators and scientists running you through all these experiments were fantastic and just walked us through every step of the way.
Yeah, just keep us posted, but Drew and I are ready to continue ops. Good working with you guys today, and I'll see you soon.
We got here on a Thursday, and it's currently Sunday. We put in a big day yesterday filling up these wells with gel solution and getting ready for handover at 7:30 a.m. on Monday, ahead of launch on Tuesday afternoon.
The mission of the International Space Station includes serving as a platform for scientific research, plus learning how to support the human crew members during long-duration missions away from the safety of Earth, and promoting international cooperation, and being a testbed for future technologies that we'll need to support our plans to explore farther than before in the years to come.
Making space for technology development. Presented by Science at NASA. The International Space Station, or ISS, is Earth's only orbiting laboratory. That's important because it not only allows us to conduct research that benefits all of us on Earth, it also provides the only microgravity environment in which we can test technologies critical to our deep space exploration in the near and far-term future. Here, engineering models can be validated, and new technologies and systems for future missions can be demonstrated, without risk to crew members. Historically, the Mercury program enabled the Gemini program, which in turn enabled the Apollo program through technology and systems advancements. Today, the space station is giving us a similar experience in long-duration spacecraft operations, and serving as a testbed for new technologies and upgraded vehicle systems, which are enabling future missions. Dave Horniak is NASA's ISS Technology Demonstration Research Portfolio Manager. He notes the ISS lets us demonstrate that a technology works as intended in a spacecraft environment. Demonstrations on the space station inform operators and flight crews how the system operates, proves interoperability with other systems, and demonstrates system safety and reliability. There are many technologies and capabilities that need to be developed as we move forward to the Moon and onto Mars. For example, researchers have recently tested a new design of solar array that will be used on the first module for the Deep Space Gateway, our future space station that will serve as a home base for astronaut expeditions to the Moon. Solar arrays in operation right now need to unfold before becoming active. But new designs allow future solar arrays to roll out and also retract. They were tested for strength and durability on the ISS and were designed to be more compact than current rigid panels. NASA's Orion Multipurpose Crew Vehicle is a 4-person exploration craft designed to take astronauts farther in space than anyone has gone before. Its backup navigation system uses a new technology that is optically based. It captures images of the Moon or Earth, and based on their size and angle, an algorithm determines Orion's location. These optics can't be tested on Earth because our atmosphere would distort the images enough to make the algorithm inaccurate. Aboard the ISS, however, the algorithm was confirmed to work properly. A secondary benefit is the system was tested at spacecraft speed, making for a realistic navigation scenario. As people travel deeper into space, they'll need solutions to a variety of safety challenges. For instance, if a fire breaks out, how fast can it grow and spread in a microgravity environment? NASA's Spacecraft Fire Safety, or SAFIRE program, has already conducted a series of experiments on 3 ISS cargo vehicles to measure flame growth, oxygen use, and combustion products. Results are helping to improve spacecraft fire detection, response and extinguishment, and crew protection. Ultimately, says Hornyak, technology and operations demonstrations occurring on the ISS today are guiding our planning, reducing risk, and providing capabilities to enable future exploration missions. For more inside information about the tech being tested aboard the station, visit www.nasa.gov/ISS-science. For more on the science of space exploration, visit science.nasa.gov.
Robotic technology, originally designed for use on the International Space Station, has found an application in healthcare as part of a telerobotic technology to provide MRI-guided breast biopsies for women in remote areas. The Canadian Space Agency contributed to the production of this feature about the innovations that are coming from the Centre for Surgical Invention and Innovation in Hamilton, Ontario.
Space represents a fairly harsh environment. Any piece of equipment that's exposed to it over a long period of time would require maintenance.
So every time we have to do a maintenance on the outside of the space station, that means a crew member has to suit up and go outside. That introduces that crew member to risk and puts that person in harm's way. The other issue is that now they're spending the time doing the maintenance work, and they're not doing the science, which is really what their purpose is. So with the maintenance challenges that we were going to have with the International Space Station, what we found ourselves was Canada being in the position to provide a solution to that problem, and Dexter was going to be that solution.
Dexter is a 2-armed robotic manipulator system capable of performing fine motion tasks to replace what an astronaut would need to do on the exterior part of the space station.
Dexter is essentially a handyman. It operates on the outside of the International Space Station. It allows us to do maintenance operations. One of the advantages with Dexter is that we're able to control it from the ground.
And so the ground crew could actually operate these robotic systems and free the astronaut up from that task as well.
So now that Dexter is online on the space station and operating on a regular basis, what we've got is we've got a crew who's spending more time doing science. And this is important because this was really the whole idea of building the International Space Station, was to be able to do science in low Earth orbit.
Unfortunately, only about 40% of women should be getting annual MRI as part of their screening undergo MR screening. Part of the reason why women were not undertaking MRI screening was because of lack of access to the best radiologists locally.
Some women have to drive very long distance, like 7 or 8 hours of car in snowstorm during the winter, sometimes risking their lives just to get their MR-guided breast biopsies.
When we started to do the research with Canadian Space Agency and NASA on the whole remote telesurgery, we started to get involved with MDA. MDA is a Canadian company which has been involved in manufacture of all the robotic systems which is currently used on the space station.
So we developed a system called IGAR, which stands for Image Guided Automated Robot.
IGAR is a tele-operated robot that performs breast biopsies under MRI guidance.
One of the capabilities of IGAR is to be controlled by radiologists from any distance. And that allows basic A radiologists to supervise MR breast biopsy on a patient who may be hundreds of kilometers or thousands of kilometers away from them. It means that the patient can undergo their breast biopsy in their own local hospital without having the need to travel to another city or another hospital to get access to the expertise.
And the results are very, very encouraging. So we've demonstrated that the IGAR is safe, extremely accurate, as accurate as a human.
And this will allow us to hopefully increase the number of people undergoing screening close to 100% where it should be. So IGAR is built on many of the know-how which was developed for the space program, as well as the software which is also used to control the robotics on the space station.
We can actually see some of these technologies we worked with for a long time becoming available. We have a lot of insight on how to apply them, not just in medicine, but in a number of other fields, which is what we're doing. So without the space station, would any of that have happened? No, not really. Not in that way, anyway.
If you want another look at any of the stories we feature today, point your internet machine to YouTube and Facebook at the addresses there in the blue box. And when you do, be sure to take a peek at the other cool stuff you'll find there about NASA and America's human spaceflight program. And when you're interested in good conversation about human spaceflight and space exploration, the place to go is Houston We Have a Podcast, where we talk to folks about their work in all aspects of space exploration. We post new episodes every Friday, and today, Gary Jordan talks with the managers of the Commercial Lunar Payload Services Program about the work underway right now to arrange to put science and technology payloads on the moon in the next few years. Go to nasa.gov/podcasts for this week's episode. It's where you also go to find all the previous episodes. You will also find the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud.